Assalamu alaikum warahmatullahi wabarakatuh. This is Dr. Ali El-Moursy, and we are in Digital Logic Design, lecture number 27. We are discussing more examples for the developing or designing the state diagram. We have solved in full the example for the serial tooth complementer with all of the needed information or the needed steps for completing the problem from A to Z, starting from developing a Mori state diagram, and then we go to from the state diagram to the state table, from the state table to the K-maps, then the equations, and finally we draw the circuit. We actually do not solve it using only one flip-flop. We actually used two types of flip-flops, the D flip-flop, the JK flip-flop, in order to fully design the circuit. And we have demonstrated what are the differences between those two solutions. Today we want to focus more on developing more state diagrams. This is actually the most challenging step in the design, how to develop a state diagram. Our next example will be about a very well-known problem called the sequence detector. So the problem is actually stating that design the state diagram for a sequence detector that can detect the sequence one zero one one in the stream of input X if the sequence is detected, the output Y equals or will be 1. Otherwise, Y equals to 0. This is actually the explanation or the narration of the problem. Design the state diagram for a sequence detector that can detect the sequence 1011 4 bits in the stream of input X. If the sequence is detected, the output Y equals to 1. Otherwise, Y always equals to 0. So similar to the two's complementer, we can actually draw a simple block diagram for the problem. The block diagram of the problem for the sequence detector has a stream of input called X and has a stream of output called Y. And I want to check whenever I get the stream of input in the pattern 1011, Y will be 1. Otherwise, Y will remain 0. Similar to the example for the two's complementer, there are two things that I have to start with. First of all, I wanted to check whether I will solve a problem as a mealy or as a Mori. For one external input, usually the difference between mealy and Mori is one extra step for Mori compared to mealy. One extra step, one extra state for Mori compared to mealy. يبقى mealy is for one input, for one external input, usually has mealy has one less state, or Mori has one extra state than the mealy. We solved our example in the last time as a Mori. So let's solve this as a mealy. By the way, the problem itself did not give me any restriction. The problem did not give me any restriction. However, I have to decide. So let's design this using mealy state diagram. This is my decision. Agree? Now, similar to what we did, we will still use the exploratory technique to solve the problem. That means I want to see here I want to explore the states. So here I'm showing the present state, okay? And here I have the input X, I have the output Y, and here I will show the next state. As we did for the other example, by the way, not all of the example like that, but this is another example of the exploratory technique is very useful to solve the problem, okay? So now I need to actually put kind of a stream of input and to show the stream of output, and in order, so this is the definition of the problem, okay? Without even developing the state diagram, I wanted to envision how this circuit is supposed to work, okay? Like the two's complementer, okay? I know the definition of the two's complementer. So here I will just show a sequence of X, okay? What kind of sequence of X? Any sequence of X. However, I wanted to make sure that I'm exercising my state diagram with as much as I can of a mix between the 1 followed by a 0, 2 ones followed by 2 zeros, 3 ones followed by 3 zeros, any mix of ones and zeros for X, okay, that actually train my state diagram, okay? So I will pick any sequence of X. So I will just assume that X is receiving as 0, then 0, maybe, then 1, then 0, then 0, then 1, 1, then 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, okay, something like this, okay. Let me just add more sequence here, okay, to make it more interesting. 1, 0, 1, 1, 0, and so on. Okay, agree? Make sense? Any arbitrary, you can see here, I'm mixing between the ones and zeros, okay? I'm not following any particular pattern, okay? I'm not following any particular pattern, okay? So 1 followed by a 0, followed by 2 ones, followed by 2 zeros, followed by 3 ones, followed by 3 zeros, whatever, okay? if you want to show more mix of this, let us change this to be even zero عشان يبقى عندي ايه 3 zeros. يبقى 2 zeros then 1 then 3 zeros then 1 then 0 then 2 ones then 2 zeros then 3 ones. Okay, so you can find here mix between 1 1 2 ones 3 ones. Okay, 1 0 2 zeros 3 zeros. Okay, you can find this A in the sequence here. So first of all, I want to know how the sequence detector works. The sequence detector is actually checking the history of X. Checking the history of X. X is provided as a sequence of inputs, and it is feeding the block, the circuit. Okay, and it should produce the output Y. Do you want only one value of X? The answer is no. I have to have a window of the history of X in order to know whether Y will be 0 or not. So first of all, why this is a sequential circuit? Definitely because it's called sequential or sequence detector. But because actually the value of Y at any given time, it depends on the current value of the input and the previous values of the input. So the circuit has a feedback. I should remember what was the old values in order to decide for the new value. I have a stream of inputs coming to the circuit, okay? But the output of the circuit will not only depend on what's coming at X, it depends only on the amount of history this circuit is keeping of the old X's. Since I want to keep the history, that means I am in a sequential circuit. I have to memorize what was the old values. The output is not depending on the current value of X, it also depends on the previous values of X. So it is a system that has a memory. It should have a memory, okay? So it's a sequential circuit. Now, as we mentioned before, so we agree that we will solve this using Mealy, okay? That means I have, first of all, let us drive Y before we go to the state diagram. Let's drive Y. So here I should collect enough of history. I am actually looking for the sequence 1 0 1 1 in the input. This is the sequence that I'm looking for. Agree? So whenever you encounter this sequence, the output should be 1. If the sequence is not detected, the output will be 0. So let us go and check that. Okay, now I have 0. Only I have a history of 1 input. So this definitely will not build up the history. So Y will remain 0 until I start building a history of 4 bits from X. So this is the first bit of X that builds the history. Do you find a match between this pattern and this pattern? The answer is no. مش كده؟ Agree? يبقى here Y should be 0. طيب. When I shift here, when I go to this input, the next one, now what is my history? I have here kind of, we call it sliding window. Each new input will actually, I have to forget an old value of input and I want to remember the new one. So if I'm checking the history, if I am checking the history here, so when I receive X equals to 0, that means my history right now contains 0, so for this one contains 0 1 0 0. Does this match the history here or the pattern here? The answer is no. So I am not matching. There is no match. You see this? There is no match. So Y should be 0. You get 0 again. Now When I go to this, I want to remember those. 1 0 0 0 1. Does this match this pattern? No. يبقى I have an output again 0. Here 0 0 0 1 not matching يبقى 0. And so on. Keep going. For this one 0 0 1 0 يبقى ايه؟ No. For this 0 1 0 1 not matched. 1 0 1 1. Yes, I get the pattern. يبقى here that sequence, the sequence is detected here. I can find the pattern in the sequence. Now y will be a should be 1. Do you agree? You understand how the sequence detector works? This is the most important thing. Then now at this bit my history is 0 1 1 0 not matching يبقى 0. 1 1 0 0 not matching. Here 1 0 0 1 not matching يبقى 0. 0 0 1 1 not matching. Here 0 1 1 1 not matching. 1 1 0 not matching يبقى 0. يبقى here also 1 1 0 0 not matching. Here 1 0 0 1 not matching. 0 0 1 0 not matched. Here 1 0 1 0 not matched. Here 1 0 0 1. Yes, I have the second match detected here. Here the output should be 1. And if I continue like this 0 1 1 0, it's not matched. I have 0 here. So actually the sequence here or the diagram here demonstrate how the sequence detector should work. Remember that you need to remember, okay, the history in order to see whether the pattern could be matching or not. Okay, so now we will go to start building the state diagram. The state diagram, as we indicated before, start with what we call the state diagram. State diagram start with what we call an initial. Let me just give myself area here. Here I want to build a state diagram. The solution. I am using mealy, okay? So mealy means what? Mealy means the output is attached to the input. It's not attached to the state. So I have here initial state called what? Called S0. I always have to start with some initial state. So my initial state here is S0. And the output Y will follow X. It will not follow the state. Okay? So now I in S0 and I received 0. I received 0. This sequence start with 0 or 1. The sequence start with 1. So the first bit to be 0 indicates that it is impossible for me to detect the sequence. Correct? So accordingly, so as long as I am receiving 0, do you want to remember any of your history? The answer is no. Receiving 0 will never, okay, will never complete the sequence. يبقى هنا ايه؟ I'm receiving zeros. يبقى هنا الانبوت is ايه؟ is zeros. I'm receiving zeros. Okay, so that means I don't want to remember anything. Right. Now, with the first, so I'm receiving x equals to 0. Where should you expect to go? I know that the output is 0, but do you want to remember any history? The answer is no. So that means as long as I'm receiving x equals to 0, y will remain 0, and I will stay in my state. There is no need for me to remember anything because I can never receive the sequence. If my present state is this is 0, I will produce 0, and the next state will be also 0. Now I am in S0, receiving 0. I am in S0. I am in S0 and I received the first 1. Now I want to remember that I received the first. I have potential to get the sequence. If this sequence is continue or completed by 1, 0, 1, 1, that means I get my sequence. So accordingly, I cannot stay in S0 because S0 indicates I don't want to keep any history. But after receiving the first one, I want to keep in my memory that I received the first one. So I have a potential to complete the sequence. So that means after S0, if x equals to 1, y will stay 0. But I have to create new state called S1. And the characteristic of this state is that I'm recalling that I'm receiving the first one in the sequence. So it's S1 means I receive the first one in the sequence. This is actually my memory. I just want to rewrite this in a nicer way. So S1 means I received the first one. Agree? Then next, I am now in S1. I am in S1 and I received 0. Do you want to remember this or not? So I want now to expand my history. I want to indicate now I received the 2 bits of my sequence. So I want to remember that I received 1, 0. So I cannot stay in this state because this state remembers only the first one. This state remembers nothing. Okay, so that means I cannot stay in S1. So I have to go to S2. Okay, so after, if I am in S1 and I receive the 0, that means x equals to 0. Y also will stay 0, but I cannot stay in state S. I cannot stay in state S. I'm trying to make it as clear as possible. I dislike that. Okay, so now I change my state to state S2, which actually indicates right now I remember 1 and 0. I remember 1 and 0. And this is state called S2. So if I have x equals to 0, I will go to state S2 and I remember that. So now I am in S2. Okay, what I received at S2 here, I'm receiving a second 0. So my history, I have in history 1, 0. If I'm receiving 0 after, if I'm now in S2 and I received 0, that means the sequence that I have is right now is 1, 0, 0. Do you have any hope to complete the sequence? The answer is no, because the sequence needs 1, 0, 1, not 1, 0, 0. Okay, so do you want to keep any history? Is there any possibility that you will build the sequence? The answer is no, because actually these two zeros break the sequence. You have to start over with a new one. When this one comes, you may have a hope to complete the sequence. So that means if I am in S2 and I receive the second zero, that means I have to go all the way to S0. Here, 0. 1 0 0 1 0. Okay, 0. That means if I'm in S2 and I receive the 0, I have to go all the way back to S0 to erase all of my history. I have no hope to complete the sequence. Now, okay, I am in S0. I received the 0. We already defined that. I'll stay in S0, and then I'm in S0 and I received 1. So I will go automatically S0 1. I will go to mean to S1. Now I am in S1 and I received the 0. S1 with 0 means I have to go to S2. Agree? Similar to the other sequence, but now I have a change. So now I am in S2 and I received 1. If I'm in S2 and I received 1, that means I have a hope to complete the sequence. كده ولا ايه؟ Let me just redraw all this. I need some space here. Sorry about that. I didn't manage my space well. So going back. So this is actually shall we draw it here? We have more space here. Okay. If I have here so this is actually S0, no memory. Okay, I'm receiving x equals to 0. This is x slash y. So 0 slash 0. Okay, so I receive the first one, and output will be 0, and I will go to S1. S1 is a memory of 1 bit, which is the 1. Okay, so now in S1 I received a 0. When I receive a 0, that means I want to go to state S2, indicating that I received 1 and 0. If I'm in S2 and received a 0, I have to go all the way, a 0 slash 0. I will go all the way to no memory. Now here S0, then 1 S1, S1 0 S2, S2 and 1. If I'm received, that means I received 1 0 and 1. Do you have hope for the sequence to be completed or not? Yes, you have. Okay, you actually wanted to reserve a memory of 3 bits. So I have to add one extra state to indicate that right now I'm in a better status. I actually received 1 0 1. Here 1 0 1. Still your output is 0, but I have to go to state called S3. Now I am in S3. I am in S3. Okay, so if in S3 I received 1, that means did you complete the sequence or not? Yes, you completed the sequence. Agree? Make sense? Now, where to go? This is the point. If I know that the arrow for x equals to 1 after S3, the output will be 1. But the question here is where to go. Now I have the sequence is completed. 1, 0, 1, and 1. In this sequence, what do you actually want to remember? This one will be forgotten anyway, but you don't know what's coming on. Do you want to remember the first 0? No, the first 0 will never complete the sequence. So right now I'm talking about after S3. So after S3, S3, okay, I already have 1, 0, 1, and then followed by 1. Where should I want to remember? I'm not sure what's coming in, but I have two options. The coming bit could be 0, could be 1, correct? No matter what will come. Do you want to remember the first 0? No. So, because you want to forget it. Do you want to remember 1, 1? No, 1, 1 is not completing the sequence. So the only thing that you have to remember in this sequence is that you received this last one. 1, 0, 1, 0, 1, and another one, you only want to remember the last one. So where to go? Where is the state where you can remember only one? This is actually S1. If you get 1 here, with 1 here, you have the output is 1. If I am in state S3 and X is 1, and Y will be 1, and I have to go back to mean to S1. Agree? Because I have hope to complete the sequence. Agree? All right. Now I am in S1 and I received 0. 0, 1, 0 means I can complete the sequence. So I will go to mean to S2. I am in S2 and I received 0. I will go to S0. I want to forget everything. So back to S0. S0 and 1. Okay, I go to S1. S1 and 1, we didn't do this curve yet, okay, this arrow yet, okay. If I am in S1 and I received a second one, do you want to remember 1, 1? No, you only want to remember 1 only, okay. So that means if I am in S1 and I received an input X equals to 1, I will stay forever in S1 as long as I'm receiving ones. I don't want to remember anything except the first one. Only when I receive a 0, I will go to 1, 0. But as long as I'm receiving ones, I only remember one of them, which is the last one. Okay? Here, 1, this is 0, 1, this is 0, 1, and here is a 0, and I want also to explore this. Let us go. So in S1, I will stay in S1. S1, I will stay in S1. S1, and I received a 0. I have a hope to complete the sequence. So I will go to S2. S2 and 0. S2 and 0. That means my history has 1, 0, 0. If you have 1, 0, 0 here, I have, so S2 means I remember 1, 0. And after 1, 0, I received a 0. That means right now the sequence is 1, 0, 0. Do you have ability to match? No, this will never match A. This will never match. So that's why we will go here to 0. S0 and the 0 will send me back to mean to S0. S0 and 1 will go to S1, S1 and 0 will go to S2, S2 and 1 will go to S3, S3 with 1 I will go back to mean to S. In order to complete, let us just uh, what if I received S3, if I am in S3, S3, sorry, here is S1, I'm in S3. If I'm in S3 and this is just for demonstration, okay? And I get, did we did it before? 1010? No, okay? So if I am in S3, I just made a modification here to address a case where I am in S3 because S3 and 1 we already covered. What about S3 and 0? If I am in S3 and I received 0, so S3 means I am in 101. S3 means 101. If I received 1, I will go to S1 and will get the output 1. But if I am in S3 and I received a 0, that means I received 1010. How my memory should be. What actually I want to remember here. What I want to recall. Okay? Is this sequence match this? The answer is no. So what kind of history? Do you want to remember the 10 in the beginning? No. You want to remember only those 10 because those has hope to complete. If those are followed by 1 means I completed the sequence again. So 1010 should send me where? Should send me to the history of 10, which is should be S2. Here, if I have a 0, I will get a 0 at the output, but I will go to S2. Okay. Now I am in S2 and I'm receiving 1. That means I have 101. So go back to mean to S3 and so on. So if you have number 2 arrows for each state, 0 and 1, 0 and 1, 0 and 1, that means you have completed your state diagram. Okay, this state diagram represents a sequence detector that detects this sequence. Now we need to shed some lights about some important observations. The state diagram that we have developed here is the successful state diagram for the sequence detector that detects the sequence 1011. The problem for the sequence detector is playing into two things. Playing in the sequence length and playing in the pattern of the sequence. Instead of 1011, I can bring you maybe 1101 or 10001, whatever. Okay? So any sequence here. So we can play with the sequence that you have for the sequence detector. But there is something that we can notice here in the sequence detector. When we built it using Mealy, the number, so for a one pattern of sequence, the number of bits in sequence, can you build a relationship? A number of bits of the sequence equals to the number of states. Okay, this is kind of a hint for these simple sequence detector problems. Number of states using Mealy equals to the number of the bits in the sequence, because each of them is actually keep track of one history. No history here, 1-bit history, 2-bit history, 3-bit history. After the 3-bit history, you will either achieve or not achieve. Agree? Make sense? Type. What if I build this using Mori? This is homework is to build it using Mori state diagram. This is your homework. Build it using the Mori and let me know what is going on. Okay, so this is the first example. We will take a little bit of break and then we will go to our lecture 27 part 2 for our next example, which is the vending machine. See you shortly after a short break. Okay, thank you.